Hello, PascoMath grade 7 teachers. Today we're going to continue our learning on 7.NS.1.1, specifically looking at part C of this standard. So let's get started. So as a reminder, 7.NS.1.1 states apply and extend previous understandings of addition and subtraction to add and subtract rational numbers, represent addition and subtraction on a horizontal or vertical number line diagram. Part C that we're focused on here says understand subtraction of rational numbers as adding the additive inverse. So P minus Q equals P plus the opposite of Q. Show that the distance between two rational numbers on the number line is the absolute value of their difference, and apply this principle in real-world contexts. So to unpack the standard a little bit, we need to understand subtraction of rational numbers can be thought of as in terms of addition using additive inverses, or sometimes referred to as the opposite. And so again, we can present students with simple equations to start, such as just something as like 6 minus 5. And so if I had 6 positives, and subtraction means, to take away, so 6 minus 5. So I take away 5, 1, 2, 3, 4, 5. I'm left with 1. And we want to connect this with our earlier understanding of adding opposites. So 6 minus 5 can also be thought of as 6 plus its opposite, so 6 plus negative 5. So if I have 6, 1, 2, 3, 4, 5, 6, and I want to add negative 5, 1, 2, 3, 4, 5. Again, my 0 pairs cancel. That makes a 0. That makes a 0. That makes a 0. That makes a 0. I have one more that makes a 0. So 6 minus 5 is 1, but also 6 plus negative 5 is 1. And we want students to make those connections. The next part talks about the distance between two rational numbers on the number line. It's the same as the absolute value of the difference between the two numbers. So if we just look, for example, using some context, the temperature is negative 6 at 7 a.m. So I'm going to go ahead and negative 6. That's at 7 a.m. And then it increases to 8 degrees at noon. And so it increases to 8 degrees at noon. And so this is 12 p.m. or noon. The temperature is 8 degrees. And so we can look at how many degrees has the temperature increased between 7 a.m. and noon. So if we look at the difference between these, so we're looking at here, negative 6 minus 8, and it's negative 14. I know that absolute value negative 14 is 14. And so here, we just showed, we can show from here on the number line that the distance between these numbers is 14. We also want to make sure to apply these principles in real-world context, just like we did here with temperature. Temperature is a go-to. Sometimes maybe we can use some other context, but I relied on it here. When looking at what the teacher should do with 7.NS.1.1c, again, link simple subtraction with corresponding addition with an added inverse on the number line. Supply students with opportunities to communicate what they are doing and reasoning orally and in writing. And encourage students to discover a formal rule for subtraction of rational numbers. Again, that should come from the students. And engage students in real-world context to demonstrate the distance between two rational numbers on the number line as the absolute value of their differences. So then the students, they need to discover that subtraction and adding with an additive inverse provides that same result. And so they will be able to discover this through experience. And so the teacher needs to set that up. Students need to clarify their reasoning about subtraction and additive inverse through oral or written communication. So once they have discovered that, we want them to report that somewhere. They need to model real-world context that involves subtraction of rational numbers using the number line. And also discover that the solutions to real-world subtraction problems using the absolute value of the distance between two rational numbers on the number line give the same result as subtracting through examples. Some students might have some difficulty understanding subtraction as adding the inverse using the number line. And we can go back to the positive and negative mats and two-color calendars for sure for students that need to use them to make sense. And so A good example would be if we had like just 5 minus 6 or 5 plus negative 6 using the additive inverse. And so if students are using two color counters, they will see if you have 5, I can't take away 6, and so there's not 6 here. And so one thing that students need to realize is go back to part A of the standard of zero pair. And so what happens if I add a positive and a negative? Does that change the value? And so like the answer is no, the value of this is still 5. And so now if I wanted to do 5 minus 6, because this still represents 5, because we have positive 6 and a negative 1, zero pairs cancel, the value is 5. I can take away 6 now. And so if I subtract 6 positives, 1, 2, 3, 4, 5, 6, I'm left with negative 1. So 5 minus 6 is negative 1. And so if they're having trouble with the number line, we can rely on two color counters for that for sure. That's it for 7.NS.1.1 Part C. If you have any questions, feel free to contact me or your regional specialist. And thank you for making PascoMath more awesome.